Hello everyone, I welcome you again to the class of econometric methods. I am Dr. Imdadul Haq. I am an associate professor at the Department of Economics, AMU. Today we would be dealing with the method of ordinary least squares and the normal equations of ordinary least squares. Basically, this formula we had this equation, that is y hat is equal to alpha hat plus beta hat x. Now we will be deriving the formula for beta hat and alpha hat. They are basically derived by two ways. One of them is through the help of normal equations. So like we have this an equation y is equal to alpha plus beta x plus e, where alpha plus beta x, this particular position is the systematic variation in y and e is the random component. E is the error term. So when we estimate it, it becomes y hat is equal to alpha hat plus beta hat x, and e, it gives the difference between the first one, that is the actual y, minus the estimated one, that is y hat. So we rearrange it in the shape that e is equal to y minus the bracket alpha hat plus beta hat x. So we further rearrange it, and then upon rearranging we finally get this equation, that is summation e square. We sum and square it. Summation e square is equal to summation y minus alpha hat minus beta hat x square. The regression line should be fitted in such a way that this summation of the square residuals should be minimum, and this we have seen in our earlier class also. This is the best method to fit a line which is through the least squares method. So this summation e square should be minimum, and this is our purpose. When we do the differentiation of it, so differentiation of summation e square divided by delta alpha is equal to 2 summation and the bracket y minus alpha hat minus beta hat x minus 1. Upon rearranging, we can write it as 2 summation bracket y minus alpha hat minus beta hat x multiplied by minus 1 is equal to 0. So now if we open the brackets, so what we finally have is minus 2 summation y plus 2n alpha hat plus 2 beta hat x is equal to 0. We rearrange it. So what we find, then we take 2 summation y, which is in the negative sign, to the left hand side. So 2 summation y is equal to 2n alpha hat plus 2 beta hat x. Now we divide both the sides by 2. So upon dividing both the sides of the above this equation by 2, we finally get the first normal equation, which is summation y is equal to n alpha hat plus beta hat x. So the similar process is to be done, the same equation which we had earlier, means this equation. The same equation we are going to differentiate it with respect to beta hat. So we do the derivation, delta summation e square divided by beta hat is equal to, again, 2 summation y minus alpha hat minus beta hat multiplied by minus x. So again we rearrange it, so it happens, it turns out to be minus 2 summation x and the bracket y minus alpha hat minus beta hat x is equal to 0. We open up the bracket, so it turns out to be minus 2 summation xy plus 2 alpha hat summation x plus 2 beta hat x square is equal to 0. Now we take this term on the other hand side, so it becomes the negative term, it becomes positive. It is 2 summation xy is equal to 2 alpha hat summation x plus 2 beta hat x square. Again we divide both the sides by 2. So finally we get the second equation, that is summation xy is equal to alpha hat summation x plus beta hat x square. So now finally we have got two equations. This was the first equation and now here we have the second equation. So we have the two normal equations, summation y is equal to n alpha hat plus beta hat x, and the second one, summation xy is equal to alpha hat summation x plus beta hat x square. Now the first equation we multiply it by summation x and the second equation we multiply it by n. So when we multiply equation 1, it becomes when we multiply equation 1 by summation x, it becomes summation x summation y is equal to n alpha hat summation x plus beta hat summation x square. This we can say as equation 3. Similarly, the second equation which we are having, this equation we multiply it by n. So it becomes n summation xy is equal to n alpha hat summation x plus n beta hat summation x square. So this becomes our fourth equation. Now what we do is we subtract our equation 4 from equation 3. The equation 4 and 3 which we have just now derived, these two we put it over here and we do the simple the subtraction of the method. Now what happens that this term and this term, they are the same. So they cancel out, they cancel each other. So what is left is summation x summation y minus n summation xy is equal to, now we have this beta hat summation x square minus n beta hat summation x square. Now what we take, we take from the right hand side we take beta hat as common. So taking beta hat common from the right hand side, our equation turns out to be summation x summation y minus n summation xy is equal to beta hat and then the bracket summation x square minus n summation x square. So finally we can write this equation in terms of beta. Beta hat is equal to summation x summation y minus n summation xy divided by summation x whole square minus n summation square. So this is the formula for beta. Now we want to find the value of alpha hat, that is the slope, that is the intercept term. Now we have the two, we take our original two equations, that is summation y is equal to n alpha hat plus beta hat x and summation xy is equal to alpha hat summation x plus beta hat x square. Now here we multiply the first one by summation x square, multiply the first one by summation x square and multiply is this the next equation, the equation number 2 over here, by summation x. So upon multiplying the first equation by summation x square, what we get is summation y summation x square is equal to n alpha hat summation x square plus beta hat x multiplied by summation x square. And the second equation which we get is, the second equation we are multiplying it by summation x. So the equation which we get is summation xy multiplied by summation x is equal to alpha hat summation x square plus beta hat summation x multiplied by x square. So excuse me. So we have these two equations. Now what we do, we minus the first equation we minus the second equation from the first equation. So we do the minus thing over here. Now when we are doing this, so ultimately what happens, we have to find this term and this term, they cancel each other. So what is left is, we are left up with summation y summation x square minus from the second equation, that is summation xy summation x is equal to n alpha hat summation x square minus alpha hat summation x whole square. So now from this we take from the right hand side of the equation we take alpha hat common. Upon taking alpha hat common, the final formula for alpha hat turns out to be summation y summation x square minus summation x multiplied by summation xy divided by n summation x square minus summation x whole square. Now this earlier method we have done it through the help of the solving of the normal equations. Now there is another method wherein we will be taking the help of deviations. So by using the deviation method we will be calculating beta and alpha over here. See, regression is independent of origin but not of scale. Measuring the slope of the line in any segment will give the same value. So we take the average value of x and y. If the regression line is passing through 0, that's the difference. If the regression line is passing through 0, then we can say that the line segment starts from 0. In that case, what we do? We forget the lower part, that is below 0, and now the line is starting from the new point of origin where the intercept was 0. So earlier the line was starting from here, but we have taken y bar over here, we have taken x bar, mean of x over here. So now my line is starting from this particular point. Now this is the value of y bar and x bar, and then we have this is our estimated y hat, this is the actual y. Our regression equation is y hat is equal to alpha hat plus beta hat x. Now what we mean by deviations of the mean is for x. We are writing here now in terms of small x. So what is small x is equal to x minus the mean of x. Small y is equal to y minus the mean of y. So now we will be talking not in terms of x but in terms of small x, which is nothing but the mean of it, which is nothing but the original x minus the mean of x. So we have this equation y is equal to alpha hat plus beta hat x plus e. What we do, we add summation sign on both sides. So we have this summation y is equal to, now alpha hat is a constant, so we write n, and over here beta hat, it was when we do the summation, beta hat is again a constant, so the summation sign appears only for x, and then we do summation e. Next we divide all the terms by n. When we divide all the terms by n, so we have summation y by n is e, and then we have n alpha hat divided by n plus beta hat summation x by n plus summation e by n. Now summation e, as we have seen in our last class, when we sum e, summation e is equal to 0. So that this term, entire term, it goes away. So what we are left with, summation y by n is nothing but y bar is equal to alpha hat, n and n cancels out, plus beta hat summation x by n is nothing but x bar. So we have y bar is equal to alpha hat plus beta hat x bar. So we have two equations. The first one was we started with the equation y is equal to alpha hat plus beta hat x plus e. Then we came to we derived just now the next equation, that is y bar is equal to alpha hat plus beta hat x bar. Now the first one we designate as 1 and the second one is designated as 2. Now we subtract equation 2 from equation 1. So y minus y bar, y minus y bar is equal to alpha hat cancels out. So what is left is beta hat x minus x bar plus e. Now y, as we have just seen, y minus y bar is nothing but small y. X minus x bar is nothing but small x. So we use the same thing and we write the equation number 3, which says small y is equal to beta hat small x plus e. Now we have this y We have this y is equal to beta hat x plus e. So now we can write this equation 3 in terms of e. So when we do this, we can write in terms of e is equal to y minus beta hat, you can say x minus x bar, or you can directly say beta hat small x. Now what we do, we use summation, summation of the both sides and square of it. So we get this equation. Summation e square is equal to summation bracket y minus beta hat x square bracket beta hat x bracket close raised to the power 2. Now our purpose is we have to minimize the errors. So to minimize this, we do the differentiation of summation e square with respect to beta hat. So now we use the same formula, which the same logic formula of differentiation which we were using last time. So when we do that, we get 2 summation y minus bx the whole multiplied by minus x. This when we open the brackets and do the multiplication of minus x, what we get is minus 2 summation x under bracket y minus beta hat x. Finally, we open up the bracket, so it turns out to be minus 2 summation xy, minus 2 summation xy. Now we are only talking in terms of small x and small y, is equal to minus 2 summation small x small y plus 2 beta hat summation small x square. Now, once we have got this, then we divide all by 2. Both the sides, the right hand side and the left hand side, is divided by 2. So 0 divided by 2 is gone. Then what we are left with is this thing. So both the 2's, here the 2 and 2 is cancelled, here the 2 and 2 is cancelled. So finally we have this minus summation xy plus beta hat summation x square. Now moving the minus term to the other hand side, so what we have is beta hat summation x square is equal to summation xy. So finally we get the value of beta hat upon rearranging this. Beta hat is equal to summation xy divided by summation x square, which is nothing but I repeat, beta hat is equal to summation small xy divided by summation small x square, which is nothing but in deviation terms is equal to summation x minus x bar multiplied by y minus y bar divided by summation x minus x bar square. Now we had this, now our purpose is to obtain the value of alpha hat. So we have derived this equation earlier, y bar is equal to alpha hat plus beta hat x bar. So to get alpha hat is equal to y bar minus beta hat x bar. So this is the formula for alpha hat, and this was the formula, either this, or you can say if you want to use the small x, that is the deviation, this is, or if you want to use the normal x and normal y, so we get this formula. Now we go a bit more, and we now try to prove that we have derived the formulas. So we proved that both the formulas one was derived by the help of normal equations, and the other one was derived with the help of deviation, are the same or not. So what is our purpose? Our purpose is to prove that beta hat is equal to summation x summation y summation capital X summation capital Y minus n summation capital XY divided by summation x whole square minus n summation x square. And this was derived through the help of, this much was derived through the help of the normal equations, and this one, summation small xy divided by summation x square, this was done through the help of this deviation method. Now, in order to prove that both of them are same and there is no difference, we do a bit of manipulation. We manipulate this by multiplying. We take this one, we take this formula and then we multiply it with -1. So upon multiplying with -1, what we get is this term which was earlier in minus. This, we just for the sake of simplicity, we write it towards this side because the minus sign is gone. So it becomes n summation x capital Y minus, we have this capital X capital Y. Now it was earlier plus, since we are multiplying it -1, it becomes minus. So it comes to this side. So what happens? It is equal to summation minus summation x summation y. So the numerator is n summation xy minus summation x summation y divided by n summation x square. The same thing we do for the denominator also. So it becomes, this is moving this side and this comes over this side. So it is n summation x square minus summation x whole square. Now we get this equation. Summation small xy is equal to summation x minus x bar multiplied by y minus y bar. That is, we just expand summation, we just write some small x as x minus x bar and y as y minus y bar. Now upon the opening the doing the multiplication, opening the brackets and doing the multiplication, what we get is summation bracket open xy minus xy bar minus x bar y plus x bar y bar. Now, so now we get this equation. Sorry. After that, we further open it. So we open the bracket. So it turns out to be summation xy minus y bar summation x plus minus x bar summation y plus n x bar y bar. Summation is applied for x, not for y bar, and again here in this case summation is applied for y bar, x bar is outside. So here, since both the terms are in mean, so what we do, we have multiplied by n. Now we open up, it means we write this y bar as summation y by n and x bar as summation x by n. So we get summation xy minus summation y by n summation x minus summation x by n summation y plus n summation x by n summation y by n. So we can cancel this n and n. So what is left is above is summation x summation y divided by n. And we have this summation divided, this is over here. This term and this term, they are as such the same. Here it is in minus form, it is plus form. So this and this cancels out. So what is left is, so when we cancel out, in the next also we can see, we cancel out this and this. So what is left is summation xy minus summation x summation y divided by n. Now what we do, we take the LCM with multiply. When we means there is this, the first term is not having in the denominator n. So what we do is, in order to take it like this, we multiply this also by n. So this equation we can write it like n summation xy minus summation x summation y divided by n. Now, so summation xy, it can be written as summation small xy, it can be written as n summation xy minus summation y summation x the whole divided by n. So earlier what we have done here, we worked with summation small xy. Now we are working with summation x square. Summation x square is, if you open summation small x square, when we open it, so it becomes summation x minus x bar whole square. Now using the formula for a plus b whole square, what we have, we can write it as summation x square plus x bar square minus 2x x bar. Now upon rearranging, what we can write it as, we just open the brackets and apply the summation sign to all the terms individually. So the first term, it becomes summation x square plus n summation n mean of x bar square minus 2 mean of x multiplied by summation x. So we have done the summation. We have applied summation to all the individual terms. Now this, what we do now, next we open up, we write x bar as x by n and again this x bar as x by n. So we write it like that, we find it summation x square plus n, again summation x divided by n whole square, minus 2 summation x divided by n. So we can write it as summation x square is equal to n, then under the bracket summation x by n whole square minus 2 in the bracket summation x, so we write it as summation x square divided by n. We try to open this over here, this term we open it. So summation x square plus n summation x by n, because it is summation x by n square, has a square term, minus 2 summation x square divided by n. Now we cancel n. So what is left is summation x square plus summation x multiplied by summation x divided by n. So this will turn, this we can again write it as summation x square divided by n. The third term is also summation x square divided by n, and here there is a 2, means it is having a multiplicated by 2. So now we can so one of them gets cancelled, this 2 cancels, so this equation can be written as summation small x square is nothing but it is equal to summation x square minus summation capital X square minus summation x capital X whole square divided by n. So we have now got what is the meaning of summation small x square. So now this summation small x square, what we do, we multiply this equation by n. It means multiply both the right hand side and the left hand side by n. So when we do this multiplication, we have this n summation square, n, this is n summation small x square, and this is n summation capital X square minus n summation x square divided by n. We have multiplied both the sides by n. So now we can write it as this n and n cancels over here. So what we have, n summation small x square is equal to n summation capital X square minus summation x capital X whole square. So this again we can write it as what we do next time, we take out n from here. We take out n from here and we put it on this side or towards the right hand side. So what we are left is summation small x square is equal to n summation capital X square minus summation x whole square divided by n. So finally we have derived through the formula of using the deviation method. We found that beta hat is equal to summation xy divided by summation small x square, and summation small xy we have just now derived is nothing but equal to n summation capital X capital Y minus summation y summation x divided by n. And then we have summation small x square is equal to n summation capital X square minus summation capital X whole square divided by n. So what we are doing this dividing by n. So because we have the formula is we divide the value of summation small xy by the value of, we divide it by the value of summation small x square. So upon dividing we get this. Now when we want to, if we just reverse it, it will become, the division sign will turn into the multiplication sign. So we had beta hat is equal to n summation capital xy minus summation capital Y summation x divided by n multiplied by n divided by n summation capital X square minus summation capital X whole square. So n and n cancels out. So what is left? Beta hat is equal to n capital X and summation capital XY minus summation y summation x capital, all in capital form, divided by n summation capital X square minus summation x whole square. This is equal to, what we have started from here is equal to summation small xy divided by summation x square. So we have as such proved that both the formulas, when we have derived, whether we have this formula we have derived by the help of the normal equations, and this formula which we have derived by the help of the deviation, they are the same. So with this I end this lecture. Thank you.